Well, hi everyone. Welcome to day 3 of our Cohere AI Hack Workshop series. Today, we're very excited to have Shamsudeen Azan Mohammed, the co-founder of Arewa DataScience Academy, with us to give a presentation on AfriSenti sentiment analysis for African languages. And it's a big honor. Thank you, Shamsudeen, for being here. The floor is yours.
Right. Thank you, Teji. I'm excited as well to be here and present our work on sentiment analysis for African languages. My name is Shamsudeen Mohammed, and a PhD student at the University of Porto, Portugal. Also a teaching staff at Bayero University, active member of Masakani NLP, Hassan NLP, and Arewa DataScience as co-founder. In this talk, what I will be doing is I will talk to us about why we need sentiment analysis to motivate the reason why, and also to discuss sentiment analysis for low resource languages, and finally to discuss AfriSenti sentiment semeable shared text we recently conclude, and present what are the best approaches we found out, to solve sentiment analysis problem in African languages. So let's get started. So why sentiment analysis? So before we see the reason why we do sentiment analysis, let me start with a basic example of why we need a computational approach to solve some of our traditional problems. If we look at sometimes, language we know is rich and diverse. You may find yourself in a community or in a situation where you don't actually speak a particular language, and you need to employ the service of translator, service of interpreter, but actually it's time consuming, this stuff, to translate. If you have huge document to translate them, it's time consuming. And in fact, we all know translation is, expensive and interpreter, and of course there is no confidentiality. You need to give you a document whatsoever it is, no matter how level of confidentiality you need to give somebody if you don't understand the language to translate it for you. I believe we all know these, issues. And now officially, we now have a computational way to, translate document. We can use Google Doc, we can use, in fact, not only translation of text, but now we can use, computational ways, many applications, to automatically translate our voice and whatsoever. And we can see here with this machine translation and, with this approach is no longer, expensive. The speed, you can translate, millions of documents in a couple of, hours or minutes. And of course, not expensive. So this is a basic something we all know, machine translation, MT, everyone knows, MT is very important, right? But someone, obviously, you may heard of sentiment analysis, why do we need this? So let's see why sentiment analysis also the same thing. We can see here, this is what we call a review. So why do we this? So, in business, people write their experience about a product. This is called a review. And we can see this guy, he had a negative experience when he bought a stuff, and someone would just go and comment, this item is not good, don't buy it, right? But the problem is when a business leaves this kind of review in their website or whatsoever, for example, in Amazon, anybody that comes to buy this item, will no longer buy this because he will see a negative review. And not only that, that person will now pass this information he saw, because we saw people tend share negative information and it travels faster. This is what we call, in psychology, what we call negative bias, meaning, humans tend to pay more attention to negative information. If it is something positive somebody wrote, this is good product, it will not even, nobody will care to transmit that information, but negative information travel up faster. So this means that businesses need to find a computational way. So as I gave an example, people need to find a better way to translate document, right? Rather than to, depends on translators. So the same way, businesses need to find a better way to, find opinion of people, because you can see a product with millions of reviews, 10,000, 20,000, right? The traditional brick and mortar business of, collecting informations is using survey. So people will share a survey, hey, give, information about my product, but this is not a scalable situation, scalable result, because now we have tons of reviews, many information online, on social media, different place on YouTube. People need to find a better way, a computational approach to solve this kind of problem. So we can see survey, similar to machine translation, is time consuming, expensive to administer, may not provide accurate representation of the population. So for example, if I'm selling stuff, I just share, a survey with some of my client, it may not actually capture the, right people. And this leads to another bias. We saw negative bias, which is called statistical bias. A statistical bias is, a kind of bias that, I show that the amount of data you have is not sufficient to, drive conclusion. So, businesses need to find a better way. And this better way business need to find is what we call sentiment analysis. So sentiment analysis is a computational ways to automatically find opinion or emotion, of people in a given text. It also moves opinion not only on text, also now we have what we call multimodal sentiment analysis using image and finance. So this is something that nowadays people do, not only sentiment analysis on text, but also sentiment analysis on, images and other stuff. So you can see here, this is an example of review. Somebody, something smells amazing, is positive review. A decent purchase, neutral, because we can just see a decent purchase, doesn't say anything positive, doesn't say anything negative, right? An absolute waste of money, this is really negative, right? So we can see now, how can we have, automate process to find this information computationally? That's sentiment analysis system. So you can see here we have sentiment analyzer, whatsoever the system is that try to find automatic opinion of the product. Sentiment analysis has been used in many aspects, politics, education, marketing, customer service, product, social media monitoring. For example, in Facebook and Twitter, you can use, Twitter to try to find out, how people perceive a particular, government, entities, and also business, customer, e-governance. So all of these stuff, sentiment analysis have been applied in all these different aspects. So we can see it's quite, not only on one sector, but different angles. But now all the examples I gave you here, we can see they are example in English, it smells good, quite decent, absolutely money. But the question is, can we do sentiment analysis on African languages, in low resource African languages? That's the aim, our own works, trying to promote sentiment analysis on African languages, low resource languages. But before we go and see, sentiment analysis on these African languages, let's see some of the, problems that, these languages face. African languages, approximately we have 2,000 African languages, however, in NLP community, in literature, they are lag behind. One of the things we can see here, underrepresentation of African languages in natural language processing. So what is this? This is ACL 2020, and in the list of, we can see 25 countries with most submissions of system. However, the dominance, there is no single African countries in this. So African languages, researchers sleeping, they don't practice, participate in this kind of research in NLP community. No, there are many problems why African researchers you haven't seen here, which we'll see here. But not only African languages, you can see from the top, some languages actually dominate the research arena. You can see we have China, US, British. So you can see the German. So you can see the countries that even dominate, research in NLP. They are, well-developed countries. But you can see Brazil at the end. We have with 8 submissions. So let's look at again, so this is also another some problem with ACL, EMLP. So it's a problem that cut across all the AI and machine learning and NLP research. African languages are left behind, and they don't actually have any publication related to that. So why is that? So what is the main blocker for African NLP researchers? So one of the main blocker for African NLP researchers is that we do have talents for African continent, and the only blocker is we don't have the right AI education. We have fewer AI researchers and also lack of funding. So these two things, non-availability of AI, experts and lack of funding, these are the main blockers for AI to shine, to African researchers to participate in AI community. But nowadays, recently, we have a kind of change in this problem. If we look at now different community, we have AI research community, we have deep in learning endeavor, we have Black in AI, and in fact, we can see now there are different, master's degree in AI, for example, from AIMS, we can see communities, Masakani, AISaturdays Data Science, AfriSenti, all these communities, they are trying to, support and, support people to be, expert in AI and not only in NLP and whatsoever. So we can see the problem we have, fewer AI researchers is now, becoming, not quite a problem, but, because we now do have, people getting into AI research, but still we have lack of funding because you cannot do anything AI, you cannot do any machine learning, NLP research without funding, without data set. So this means that in African NLP researchers, they also suffer, suffer from availability of data set they can use for their own research. And this problem still persists. That is one of the main blockers for people they are not engaged in research. If you look at this, Landfrica, which is a database that, house data set for African languages. When you did a quick search, you can see for all those, 2,000 African languages, there are only 7 data set available for sentiment analysis in African languages. You can see this is kind of, this disparity is quite, alarming. I mean, of course, you not see research in because, we have fewer data set, and some of these data set, to make it worse, they are translated. So for example, you see a data set in sentiment analysis, but it was translated from English to African languages, which also introduced some kind of bias, as we will see. So if you look at this one here, sentiment analysis from Landfrica, you can see we have very few sentiment analysis data sets, but for MT machine translation, we know MT is quite robust. You can see we have many data sets to do that, and we have many researchers, but for sentiment analysis, you can see they are quite very few. So this is one of the, problem, but thank God now we have many funding coming to African researchers to support their research. We have Lacuna Fund, which basically comes to, to actually support African languages, low resource languages to develop, data sets for, to solve African problem. We can see lacuna, which is basically a gap. So they are trying to, solve such kind of gap by bridging this kind of lacuna. And our team basically, are these numbers really few or just, yeah. So I basically did a search in Landfrica, and if you go to Landfrica, because they house this kind of data set. So if you go to Landfrica and you select sentiment analysis, these are the figures I found. So yeah. So, our project, AISaturdays, which is sentiment analysis for African languages, was supported by Lacuna. Our project AfriHate, which is hate speech for African language, was supported by Lacuna. And also we recently conclude AfriSenti Semeable, which is basically Semeable, competition for sentiment analysis in African languages, is also supported in some ways by Lacuna Fund. So we can see Lacuna Fund is actually trying to, bridge the gap by allowing Africans to create African data set, which would also, fuel research in African languages. And thanks to Lacuna for, that. All right, so that is, some of the problem we have in African languages, lack of availability of data set, which, stop us from doing research. But now, thank God we have, few data set, we can do that. So we started with AISaturdays, because if you want to solve problems, start with small problem, right? So when you solve a small problem, then you can expand to, do a lot more. So what we did, we start with AISaturdays, which is basically a sentiment analysis in Nigerian languages. And we basically, successfully, conducted the research. And, you can see it's a lot of, collaborative work with different people, those that speak language expert, and also, people from the community. We did a lot of contribution. We released a level data set for 4 Nigerian languages, Hausa, Igbo, Yoruba, and Pidgin. We, released a level data set, the highest, on-level data set in Africa, in Nigerian languages. We released that. And, we also annotate sentiment lexicons in Nigerian languages, Hausa, Yoruba, Igbo. So what is sentiment lexicons? Words that shows sentiment carrying word. For example, good is bad, all these ones, we read them. They are useful also in sentiment analysis research. And we also train various pre-trained models. We release the code and, whatsoever to promote research in sentiment analysis in Nigerian languages. So this is our first main contribution in sentiment analysis in Nigerian languages. And this contribution actually motivate us to, to work more. And we didn't actually, do any translation here. For example, as I show you, some of the data set were translated from high resource languages in African language, but we create this data set from scratch. So this is a Twitter data set. We crawl and we hire annotators and we crawl. And we annotate approximately for each language, we annotate 30,000 tweets. And so this is the largest Twitter data set available so far on any languages in African languages. So based on also Lanfrica, and this is the largest data set based on Lanfrica. Now, we encountered a lot of challenges when creating this data set, and we, wrote this in our paper, which people can read if you're interested, which is a Twitter Academic API, emoji language detection. One of the main problem I want to talk is, Twitter supports 70 languages through their API, and only 1 African language is involved, which is Amharic. Among the languages that Twitter supports, there are some languages that they don't have even up to 10 million people. But in African languages, we have Swahili with more than 100 million people. So this kind of systematic bias, and inequalities actually fuel the, this kind of, non-availability of data sets. So right now, Twitter also is going into another crazy direction. From today, I think Twitter is closing their API. If you want to get Twitter data set, you need to pay. Elon Musk is doing stuff. So I was reading, if you want to get, for example, people need to pay about $42,000 to get access to Twitter data set for certain numbers. And if you want to get 5,000 tweets per month, you need to pay $100. So Twitter is monetizing their data set. But thank God we got this data and whatsoever. So we also, conduct a lot of, analysis. One of them is code mix. We understand, Nigerians are African, not only Nigerians are, multilingual, and, all our data set are code mix. And one of the main things I, remember is that a lot of people will say, hey, sentiment analysis is a solved problem. Can we use the approaches that have been used in English, in German, just to solve sentiment analysis because it's no longer a problem? But African languages, we have domain context dependent. Language is dependent. Is specific to to particular community. So you cannot say the only way that you solve problem in English, you just solve it. So there are many things. So for example, tonality challenge in Igbo or Yoruba, tones actually matters in the sense that I'm not your boy here, but maybe Teju, can you help me to say these ones?
Okay. Àwọn ọmọ for abo. That's
Yeah.
the first one. Like children are washing dishes. Àwọn ọmọ for abo. And the other one, àwọn ọmọ for abo.
Is it the Yoruba or Pidgin?
It's Yoruba. So the second one is like four is to break. Four is to wash. It's like four and four. So that's that's what differentiates between two sentences.
So you can see only this accent, changes the sentiment of this. This is positive. This is negative. Only this. So you can see the tonality, the way somebody tones. So you can see African languages, they have their specific problem, specific, things that we need to address. So these are some of the challenges you can see we find out, and we need to develop models. We need to come, best way to deal with this kind of problem. So that's sentiment analysis problem we encountered, and there are many ways now that I would move on, not only about the data set, but computational ways, how we can, solve sentiment analysis, how we can do sentiment analysis. So we can do sentiment analysis basically using either lexicon-based or machine learning or deep learning. Let me just start with the lexicon-based. So how can you do sentiment analysis? So given a tweet, I love the car. What you need to do in lexicon, from the word lexicons, you try to find out what are the positive lexicon in a text, and you classify it as positive. So here, because I have love, so all these kind of word, we call them lexicon, you put them in a dictionary. So you can see this is a dictionary. And now when you have a text, for example, whatsoever, so you try to find out, does that text contain some word in positive or negative dictionary? If it is content, then you say it's positive or negative. This is sometimes called dictionary-based or rule-based or whatsoever. But this is not scalable solution. It doesn't work in all situation, because you can see this one, his pain, for example, here we have the stock price is increasing. This is positive in which domain, economic or whatsoever domain. But we can see here, you say his pain is increasing in, medical domain, his pain is negative. He is mad programmer, in nowadays, because the word mad changes from negative to positive. Mad program is excellent or good program in some ways. So lexicon-based sentiment analysis cannot be used effectively to solve sentiment analysis problem. We need a better way. Thank God now we have many approaches, and these approaches has been used in our low resource African languages because they don't have data set, they have lexicons. So we can see here, for example, this is a paper, they use lexicon based, they translate the lexicon. Another one here also they use lexicon, they translate lexicon, but lexicon-based sentiment analysis or translations alter, sentiment of a word. So for example, this paper, what they did is they take a lexicon in one language, in English, and they translate the lexicon into Igbo, and they did sentiment analysis. The problem is this sentiment translation alter sentiment. So let me show you an example. Here, this is something someone, wrote in Facebook in Hausa, mashallah, Allah ya azurtani da samin karuwa that Tanamiji. Somebody is, saying he was happy his, wife gave birth to a baby. But you can see when the Facebook did a translation, may Allah bless me with getting my prostitute. So you can see the translation changes to something negative. You can see prostitute, so we can see, it changes the sentiment from positive to negative. So translation actually alters sentiment. So we need a very good data set, that is, created from scratch that allow us, to do sentiment analysis. And, lexicon based, as we can see, is now a better way. And we can use machine learning and deep learning approach now to do sentiment analysis, which actually, take care of context, because deep learning now is contextual embeddings. This is what you're going to be doing with Cohere AI. They will provide you with embeddings. Those embeddings are contextual. They will learn the context when you say, for example, here, Karua. So in Hausa, this word Arua, it can means, give birth. If you put it in another way, Karua, it means prostitute. So embeddings allows you to know what context a word is used, and it will apply, the correct word. And Cohere AI will give you access to their embeddings. Then you can exploit that embedding to solve many problems. One of the one of the things you can do sentiment analysis using embeddings and whatsoever. But yeah, so this is just what you can do. So let me now take you to some of the solutions we built on sentiment classification using AISaturdays. So we did a bunch of experiments using pre-trained language models. You can see we use multilingual pre-trained language models, MBAT, SLMR, AfriBata. We use language adaptive fine-tuning. We use multitask. We use zero-shot cross-lingual transfer. These are all approaches to solve problems. So let's look at this. The first one. So the first one is called multilingual pre-trained language fine-tuning. So what is the meaning of fine-tuning? So nowadays, fine-tuning is the gold standard. I mean, it's the first thing you do when you want to solve, deep learning or NLP problem. What is the meaning of fine-tuning? So some of us may not be familiar with what fine-tuning is. So if you want to solve a problem, you take a pre-trained language model, right? Example, BART, GPT, or whatsoever, and fine-tune it on relevant task data, and you use your classification. That's what we did the first one. We took, all of these pre-trained language models, MBAT, SLMR, AfriBata, MDBata, and REMBata, and we fine-tune them, meaning we use, another data to fine-tune to relevant tasks. And these are some of the results. So you can see here, we have multilingual pre-trained language models. We have AfriBata, MBAT, SLMR. And, these pre-trained language models, they have been pre-trained on several languages. We can see here, AfriBata was trained on 4 Nigerian languages. MBAT was pre-trained on Yoruba only. SLMR was pre-trained on Hausa only. And MDBata was not pre-trained on any Nigerian languages, and REMBAT was trained on these languages. And we can see the, performance of these models. We can see that AfriBata actually performs better and is the winner. Why? Because AfriBata is a small model, but was pre-trained on Nigerian languages. So it means AfriBata has seen Nigerian languages and it performs better. However, we can see also, MDBata, which was not trained at all. It hasn't seen any Nigerian languages, but it performed closely to, AfriBata, rather even much better than REMBata, which was also, which has seen Hausa, Igbo, and Yoruba. And this is impressive performance. This is basically what we did with fine-tuning. But can we do better than just normally fine-tuning? Yes. That is what we call continual pre-training. There's a question, what makes MDBata performs better? So even though it was not pre-trained, on African languages. So what makes it better? So we actually don't know what makes MDBata makes it better, but maybe it relates to pre-training. MDBata actually make use what we call, replace token detection, which has shown impressive performance also in English and many other tasks. We are not sure, so maybe the pre-training, code mix in Igbo tweets. But also other languages, they also have code mix, right? For example, right. So if we go back here, yes, maybe it is give us, if you go back here, which I made mention, we can see here, we have our tweets. We can see here, Igbo. The tweets are basically code mix, maybe 50%. Can we see that? 50% of either tweet are, code mix, meaning 43%, I think they are, code mix, and, only 57, they are monolingual, meaning that code mix, it means it contains English and Igbo. And we can see that and MDVATA was basically trained on English and many other languages. So maybe this explains some of the performance of MDVATA on Igbo, but not, but in fact, also we can see it consistently across, Hausa, even though Hausa does not have a very large amount of code mix, it has 79, better than, MBAT, which has seen, XLMR, which has seen Hausa in training. So yeah, so but I think this can explain why MDBATA was also good, but consistently MDBATA you can see it performs better. And so can we do better than just fine tuning? So here is fine tuning the same as transfer? Yeah, so this is a good question. Somebody is saying, is fine tuning the same as transfer learning? Yeah, that's transfer learning. So what does this mean? Now here is pre-training. You train a language model, which we call pre-training, on level data. Very large amount of data. You train a language model, and now you fine-tune, which also transfer learning on tax data. So if you are doing sentiment or machine translation, so this is typically what we call transfer learning. Yeah, you are right. Okay, so yeah, can we do better than just fine-tuning? Yes, we can do what we call continual pre-training, and this has been proven to be effective way to actually solve, problem to continue pre-training models rather than just using fine-tuning. So this is one paper that do that. So what is free continual training? Sometimes continual pre-training is called adaptive fine-tuning. So these are two terms that you find them in academic, interchangeably used. So what is the idea about this? So you have pre-trained model trained on large data. And now, for example, here, we can see here SLMR was only trained on Hausa, right? It has not been trained on Igbo, Yoruba, and whatsoever. Now, I can take any pre-trained model. Now I continue pre-training it, not only fine-tuning. So it means now there is two pre-training. The first pre-training, then there is another pre-training. So this pre-training that you continue, you also get a very large corpus in a particular language. So for example, let me give an example. Here I have MDVATA, which was not trained on Hausa, Yoruba, or Igbo. Now, if I want to do continual pre-training, I need to get a corpus for Hausa, Yoruba, and Igbo, and take MDVATA and continue pre-training it. That is called adaptive pre-training or adaptive fine-tuning. So that thing will actually has been shown to increase performance, and finally you can do fine-tuning. So we have three different kinds of adaptive pre-training. We have language adaptive pre-training. Language adaptive pre-training is that if a language model has been trained on English and you want to transfer it to Hausa, then I need to get more data on Hausa and continue pre-training on it. That is called language adaptive pre-training. But also there is what is called TAP adaptive pre-training, and this is called LAT. That's also called task adaptive pre-training. So if I want to do sentiment analysis and I have pre-trained language model, for example, BAT. Now, if I want to do sentiment analysis, then I need to take my training data for sentiment analysis, training data, and continue pre-training on training data. That is called task adaptive pre-training. So you continue pre-training on the task data. There's also domain adaptive pre-training. So for example, here I have a BAT, which was trained on a general corpus. Now I want to apply BAT on medical field. Now what you need to do is get some more data on medical field and do continual pre-training. That is what we call domain adaptive pre-training. So we have three kinds of adaptive pre-training: language adaptive pre-training, task adaptive pre-training, and domain adaptive pre-training. So what we did is we did what we call language adaptive pre-training. And we can see here, we can see here, we did language adaptive training left. So for example, we take MBAT and SLMR. So we take two pre-trained language model and we continue training. And we use general corpus, and we use a domain-specific tweet corpus. And as you can see here, we use the left here, 81.5. You can see here the performance here, SLMR was a winner using left. But we use general corpus here, not tweet corpus. And the general corpus, the main reason is that the general corpus we use here is large enough. That is why the performance increased. So that is multilingual pre-trained language model for us left. And yeah, now we sit down and say, okay, now we solve Nigerian problem. We create corpus for Nigerian sentiment. Can we do better? Can we extend AISaturdays to, maybe AfriSenti? Yes. So that's what we do. We extend Nigerian sentiment analysis corpus to Africa sentiment analysis corpus. And not only that, we organize what we call a shared task or a competition that tries to, we try to invite other researchers, not only from Africa, but researchers from, around the globe, from China, from Germany, from US. We invite them to compete to try to solve sentiment analysis problem that only, African languages. And yes, so we have question. Will you have to do this adaptive pre-train on each language or all of them at once? Why use MBAT as pre-train model and not MBAT? Oh yeah, so this is a good question. Why we didn't use MDBAT? So MDBAT, they didn't release their code at that time, it's closed, but MBAT was open. So anyone can use MBAT. SLMR also was open. You can use MDBAT, I believe from Facebook, Meta, right? So at that point, MDBAT was closed. So there is it's not available that we can do pre-continual training on it. So, so what is SemiAble? So SemiAble is basically a shared task or competition that try to solve, sentiment or semantic evaluation. It's different from other competition such as, Zindi or Kaggle, in the sense that this is ACL based, workshop where when you participate, you write a paper, you attend a conference, and you can meet people and discuss. And you can see SemiAble has been in existence since '98, and you can see it has been in existence, but there wasn't any African languages. And our own task, SemiAble for sentiment analysis for African languages, was the first competition that involved African languages in SemiAble. And you can see here SemiAble. And since 2013, there are many sentiment analysis. All these guys, they are in English. You can see them consistently in SemiAble. There are sentiment analysis or latest tags on English on shared tag, but there isn't anyone for African language. And our own shared tags, SemiAble, try to break this monopoly. You know what I mean? So we have SemiAble and try to do that. And why do we promote this? Promote SemiAble, try to solve African, promote NLP research in African languages, for student opportunity for them to write paper, attend a conference. And of course, we put, award for best people, best system. We have 5,000 USD for best system. And also we have best paper award. And you can see this is, the languages. We have 12 languages. You have different subtags, multilingual, monolingual. We have zero shot. And the SemiAble, workshop will be co-located in ACL 2023 in Canada, Toronto. And, we receive a lot of submission from different teams. So you can see this, some of the languages we have, Hausa up to Oromo. We have monolingual, we have multilingual, we have zero shot. And these are the subtags we have. And we receive a lot of submissions in our system. We have over 500 submissions, people trying to solve the problem. And among these people that participate, some of them wrote a paper. So we received 29 papers. So people wrote a paper describing their system. They submitted to the workshop. And now, they will attend the conference in Canada. Now, previously, you saw that we show that actually in those days, previously, AfriBata was base system, right? AfriBata won here. You can see AfriBata. At this point in time, it was only pre-trained language model on African languages, AfriBata. But now, after AISaturdays in our AfriSenti, there is a new model called AfroSLMR. Now, what is AfroSLMR? if you can see here, as I showed you here in our AfriSenti and AISaturdays, SLMR plus LAFT, language adaptive pre-training, achieve a very good performance, right? Now, this shows that if we scale SLMR, we do adaptive pre-training with more data, because this is a few data. If we can train SLMR with very large amount of data, it can perform across African languages better than AfriBata. And this is what happened. So Jesse Joba and David, they took this further. They do continual pre-training on SLMR with more data. And now Afro SLMR is the best system that perform well on different tags on African languages. And this evidence comes from our shared tags, where many participants that participate, the best system was basically on Afro SLMR. As you can see here, we have many systems. There's top system, we can have NLND, you can see we have subtax B, we have subtax C, these are the system. And all these, system, these teams across, they do Afro SLMR. Let me tell you one interesting things that this winning system did. So these are some of the teams, you can see them. Bosch Center for Artificial Intelligence in Germany. We have Field Life Insurance from China. We have these guys from Luxembourg and Morocco. We have this LISAC, which is from Faculty of Science, Morocco. We have George Mason University from US. We have Howard University from US. These are some of the few systems that stand out, but we have about 29 of them. Please read our paper, AfriSenti Samable. It is there. We have explained all the system, and you can learn more about them. So these are the systems, but the question is, how they won their system, how their system won. So if you look at this NLND, I already told you about adaptive pre-training, right? So all of the continual pre-training, all these systems that stand out, what they were doing, they are doing continue pre-training. Can you see continue pre-training, continue pre-training, adaptive. So this means that to solve African problem, what you need to do is just do continual pre-training. Don't stop pre-training, do continual pre-training. The best system, which is NLND, let me show you what they did. This is the best system across our shared tags. No language, no data expertise. So they call their team NLND. They don't know the language. They don't speak Hausa. They don't speak Yoruba. But we have people that are Yoruba. We have people that are Yoruba in Hausas, but they were not able to, beat these guys. They are from Germany, Bosch Center. But what they did, this is what they did. First, they did LAFT. What is LAFT? Continue pre-training on language. So they take Afro SLMR, which I told you was the best now language pre-trained language model. They took SLMR, Afro SLMR. They do another LAFT. They get more data. They do LAFT. That's the first thing they did. So when they did LAFT, it means their model now understand more about these languages, African languages. But they did the LAFT with more African languages. Now they did only LAFT. If you remember, the Afro SLMR, what they did is only LAFT. They did only LAFT, language adaptive pre-training. But I also told you we have another kind of another stuff which is called not LAFT, but we have what we call task adaptive pre-training, TAPT. What is task adaptive pre-training? When I want to do sentiment analysis, I have my training data. I will take that training data and now do continual pre-training on it. That is TAPT, task adaptive pre-training. So what this team does is that they do two free continual training. They did LAFT. They get more data on these African languages. They do pre-continual training. And now they do TAPT. So they combine LAFT plus TAPT on the training data we provided. And now, boom, they achieve the base system. So LAFT, we understand in conclusion, to leverage LAFT, language adaptive pre-training, and TAP will achieve best system in sentiment analysis. And we believe not only in sentiment analysis, across different kind of, tasks, NLP tasks, it will be a very competitive task. Thank you very much. And happy to answer your question, if any.
Thank you very much. A virtual round of applause to you for that awesome presentation. Really learned a lot. And I was also very curious about one of those winning teams. They actually did continuous pre-training on MD Beta, I suppose. Is it now publicly available for people to use?
No. They use pre-continual on AfriSLMR.
I thought I saw MD Beta, maybe.
No. Yeah.
Afrix.
Yeah. So all the winning teams, they did pre-continual training on AfriSLMR.
I see.
Yeah.
Awesome. Do we have any question from the audience? So one cool thing about what Shamsudeen have just taught us about is that now you can think about using some of this, the Cohere embedding to solve problem like sentiment analysis, right? So it's just mentioned that, like, also maybe think about how to use the embeddings to better label the sentiment of a sentence to see how the performance is. And you can also maybe train your own small model by first labeling, using the large language model to label. You of course verify, and then you can now maybe fine tune your own model to see how it works and things like that. So there's really a lot of flexibility as long as you're dealing with text. I think there's a question in chat. Oh, I think the question is for the organizers, which you're also part of, Shamsudeen. So it says, is our project supposed to have multilingual embedding? Yes, essentially the model itself that you have to use if you want to qualify for the prize is the Cohere multilingual embedding API. But your project does not necessarily have to be a multilingual project, right? You could focus on one language and to solve a problem, but you have to use their multilingual embedding to solve that problem. Is that understood? Thank you for sharing more links on continual training. I will post that also on Discord so that we don't lose it on chat. Do we have any other question for Shamsudeen?
Yeah, so somebody was asking, can you explain more on the pre-continual training approach? So yeah, I think as I said, the pre-continual training is sometimes called adaptive fine-tuning. You may find it somehow confusing. People use different terminology to describe this. But what is happening basically is this. What do we mean by pre-training? So in NLP, what we mean by pre-training is basically you get a very bunch amount of corpus or level, maybe on Wikipedia data, whatsoever data, very large corpus. For example, let me give an example in Hausa. You can get very large amount of Hausa corpus in terabyte or whatsoever, and you do what we call create a model by doing what we call pre-continual training. So let me share my screen again so that I can maybe better go back to pre-continual training. Okay, so Yeah, so this is, you have internet here, we know, and you have corpus. So you do what we call pre-training. What pre-training allows you to train a model on large corpus, and the result of pre-training will give you a model, example of the model such as BART, and the resultant model such as BART learns or knows a lot about the language, a lot about the syntax about the language. So if you want to do some tasks, you can basically do fine-tuning. But the other one, which is adaptive pre-training, basically when you have a pre-trained model, you want to adapt the model because the model was pre-trained on different language, for example, language English, and you want to use BART on Hausa or on Yoruba. For example, let's assume BART was not pre-trained on Yoruba and Hausa. Because BART was pre-trained in English, it understands a lot of language stuff. You can teach it more Hausa, more Yoruba. That is called adaptive pre-training, continue. So you continue pre-training and get another corpus, large corpus in Hausa and Yoruba, and continue pre-training it. So that's a basic stuff, but I think I share 2 resources, one paper on don't stop pre-training and also Sebastian Ruda on, continual pre-training. I think that will be helpful to understand more about this stuff.
Idris, go ahead.
Okay, thank you, Shamsudeen, for the wonderful presentation. My question is with regards to the multilingual embedding. So I went to the playground that was provided on Cohere's website, which I tried to use a little bit of the multilingual embedding to see its capabilities and the rest. So I tried to generate something in English, and it was relatively good. But then when I switched to Hausa, it became a little bit not as good as English, let's put it like that. Then I checked to see whether it really supports Hausa language, and I saw that there are a list of 100 languages in which it supports generation and other manipulation. Then so let me leave it at that. My question here is how, because you said we may focus on multilingual settings or just focus on one language. So let's say a person wants to execute a project in Hausa, and then maybe using that embedding give some underperformance, let me put it that way, not being critical. So how will that affect the ranking? Maybe let's say the ranking, because the idea might have a mark here, but then the accuracy of those type of model on a language, let's say as low resource as Hausa, how will that affect standing on either getting a prize or not getting a prize, so that people will not just focus on English because it maybe is the best represented language on the multilingual model?
Oh, I think that is an excellent question, Idris. Thank you. And indeed, it's very, very possible that the model would underperform on low resource language, which is part of what Shamsudeen have already mentioned, that it is quite challenging, and unfortunately, not a lot of big models out there support very well the low resource languages as much as we would like them to. But we also see that a lot of them now are putting in effort to collect data set and to train this multilingual models as Cohere has done. So I think it would be also nice to look at the size of the data set per languages that Cohere trained on for their multilingual language to see how much of Hausa was actually represented in their data set. And that to your question on when you generated when you looked at the embedding for the Hausa sentences, and you did generate a new text. So it means you're using the generate API, right? You're not just using the embeddings, or you're not just looking at the embeddings to maybe calculate the similarity across sentences, but you're actually generating a new sentence. Is that correct?
Yes, I used the multilingual embedding to see the similarity between sentences, but also what I was asking about is the generate function, where you might give a language model like a question to either generate this kind of data for me. If you give it in English, the data like is much more closer to your query than when you give the data in Hausa. So a lot of what was generated before was even in English. Then the language that I couldn't understand, then what I did was to put in Hausa, then colon, then state my question also in Hausa. I was trying to get the model to focus more on giving me something that is Hausa. So I gave it Hausa, colon, then the question. Then there were appearance of something related to Hausa, but then most of it that was generated is English. But then the Hausa started appearing by giving it the right prompt. Yeah.
Well, thanks for sharing more about this. So for this hackathon, again, the technology that we will make sure to judge on would be the Cohere multilingual embedding. So you don't have to use the generate or the classify or the other API the Cohere provides, but it's a nice addition if you did use them. But if you don't use the Cohere multilingual embedding API at all, then it's a huge negative, because this is the technology that the hackathon is focused on. But let's say your solution now uses a mix of these embedding to now generate, to use some other high quality large language model that gives you better generation in terms of like the text generation. Well, you cannot be counted against for that, because also you're meant to showcase a project that has some useful application that is creative. So it's like end-to-end tool. You would use other tools for sure. You would maybe use Streamlit to build an app, or consult some other API to do something to incorporate in addition to using multilingual embedding API to generate this embedding. So we will look at all of those. They, of course, like the judges will consider all that. Again, to mention, if you use all their API, it is a nice addition which would be considered, but the API of focus right now for this hackathon is the Cohere multilingual embedding, and that has to show up in your project. Is that something that clarifies your doubt a bit? I also want to note that we can also, if you are thinking about ways in which we can help Cohere make their Hausa generate function better, maybe by fine-tuning, or like, using the model that they have, and then putting some new sentences to train, to do continual training. Like Shamsudeen has said, that would be very helpful, right? Like, we want it to be better on the languages that we care about. And it's I would say, unfortunately, the world right now is very biased. So that's why, like, a lot of the work that Shamsudeen is doing, Masakani is doing, to curate more data set, my community is also doing in the aspect of like accented speech, to just create more data sets, to have more representation about the languages, the context that we all care about, is extremely important. And if you are able to like improve it, right, in some way, I'm very certain that this is something that Cohere would want to, like, fund, to sponsor, to encourage, and also to showcase, and put in their own resource, or to help improve the Hausa representation or like the generation within their data set. So it's very, very welcome. It could be that the project that you come up with would be to showcase that this model is not doing well on the language you care about, and then propose a way in which it can be improved. I don't know, some projects like that. So it's useful. It's they can learn from it, they can improve on it, and hopefully it's better for the next hackathon for Hausa, just because of your input.
Yeah, thank you, Teju. I have also another question. Last time in our meeting, I think somebody was asking, the participants, are they, going to develop only applications, or can they develop a model, train a model that they use multilingual embeddings only, or must they develop an application, or they can develop a model that utilize a multilingual embeddings?
Well, at this point, I think if they are able to develop a model like that utilize the embedding as an engine, that would also be very much encouraged. And like it does not have to be just an application that is like fully fledged from end to end. It could be in that direction where it's data science, like you're developing a model. The reason why we were leaning towards the application side of things is because like a lot of these models are not open source, so you have to interact with the API to get it's query based, so that's why we thought maybe thinking about an application where you want to solve like you have a project in mind and you want to solve that could be useful. But if you have a way to still utilize the model, right, to pre-train or like to fine-tune some existing model, I think that would be very much welcome. And also, as Roy put on the channel, when someone asked that about the custom model, they also support custom model. So you can custom model in the sense that you can give data and train, customize their model to your own data set, I think. So, and Roy mentioned that you can create a custom model using their Cohere API key, and he said that there are a ton of open source data sets that is available on Kaggle or Google, which we can use to customize your own model. So I think it's supported. You can customize the model.
So you mean we can customize their model or embeddings using our own data to do continual training?
I think so. Yes, I think it's supported. So that at least that was what Roy mentioned. But to just clarify, you can also like on our channel, the Cohere AI Arc, not the organizers one, the main channel. Just we just do @Cohere and ask the question again, and people from Cohere can let us know. But as of the last time, Roy mentioned that you can create a custom model. And I also I've also watched a couple of videos that seems to tend towards that. I have not created my own custom model, so it would be great, like, if Idris already want to test that out to see maybe if this is something that is doable and you can share with other hackers and they can know, and we can we can also like customize the model to your own context.
Okay, thank you, Tej.